Welcome to the deep dive. I want you to picture something for a second. $176 billion.
Yeah, which is just a staggering amount of money.
Right. And if you are listening to this right now and guessing that figure represents, I don't know, like a new national highway bill or maybe the capital expenditure for the next wave of those hyperscale data centers, you'd be wrong.
But, your mind is definitely in the right place.
Exactly. Because we are talking about a physical footprint of that exact magnitude. Right now, there is this hidden $176 billion global pipeline that is just quietly becoming the most lucrative new construction category in the heavy industry sector. And it's happening right in our backyards.
It really is. It's the quietest gold rush in modern construction history.
Totally.
We are looking at this unprecedented boom in SMR, so small modular reactor construction. And it is completely rewriting the rules of infrastructure development, supply chain logistics, and honestly, how commercial contractors actually scale their businesses.
And our mission for this deep dive is to break down exactly what this SMR gold rush looks like for you. We really want to understand where it's happening, why the economics have suddenly shifted, and most importantly, how contractors are positioning themselves right now to win decades of highly specialized work.
Because this isn't just, a slight pivot in energy policy.
No, not at all. It's an absolute seismic event for the construction industry. And if you are in the heavy civil or industrial sectors, this is the wave you absolutely need to be tracking.
Yeah, and to set the stage for just how vast this is, we can look at Smart Business Automator's Market Intelligence Report, which details the sheer scale of the current mobilization.
Right.
We are talking about 22 gigawatts of new nuclear power actively being developed across 9 different U.S. states.
Which is huge.
It is. That is not a localized pilot program or, some academic experiment. That is a synchronized nationwide infrastructure rollout. And it demands a level of coordination, capital, and skilled labor we just haven't seen in a very long time.
Okay, let's unpack this, because we already know the industry standard for these small modular reactors, or SMRs, targets a really high fabrication rate, right? Like an 80% factory fabrication rate.
Yeah, roughly 80%.
So what I really want to know is how that shifts the risk matrix for the general contractors out on the site. Because when you think of historical nuclear builds, you think of these colossal, monolithic mega projects.
Oh, absolutely.
You think of a 15-year engineering nightmare where, every single problem is a bespoke issue that has to be solved out in the elements.
Right, and historically, you'd be entirely right. Traditional nuclear plants are the ultimate site-built monoliths.
Yeah.
Every single piece of a traditional plant is practically a custom engineering challenge that gets solved out to the field, which is exactly why they typically run billions over budget and, take well over a decade to complete.
But SMRs are different.
SMRs fundamentally change that equation. We are looking at 3 to 5 year builds precisely because of that 80% fabrication rate you just mentioned.
Okay, so most of it is done off-site.
Exactly. The bulk of the complex, highly sensitive nuclear components are built in a heavily controlled, pristine manufacturing facility, and then they're just shipped to the site as pre-assembled modules.
So it's less like traditional heavy construction and more like aerospace manufacturing, maybe?
That's a great way to look at it.
Like you're building fuselage sections in different states, shipping them across the country, and when they finally meet on the tarmac at the job site, the tolerances have to align down to the millimeter.
Yep.
The pieces arrive perfectly formed, and the job of the on-site contractor is assembly, integration, and structural support.
That is the perfect analogy. And what's fascinating here is how that aerospace model applies to construction risk. It's revolutionary.
Because it's predictable.
Exactly. By moving the hardest, most sensitive parts of the build into a climate-controlled factory, you eliminate a vast chunk of your variable risk. Think about weather delays, site logistics, the complexities of pouring, like highly specialized containment concrete in the dead of winter.
Oh, yeah, that sounds like a nightmare.
Right. You strip all of that away from the reactor core itself. That predictable timeline makes nuclear energy scalable, and crucially, it makes it financially viable for private capital.
Because investors hate uncertainty.
Exactly. Investors aren't paralyzed by the fear of a 20-year open-ended capital expenditure anymore. They are looking at a predictable, highly managed 3-year deployment.
And if these reactors are essentially being deployed like manufactured goods, the immediate question for anyone listening in the industry is, well, where are they landing?
Right.
Who is actually getting the labor and the contracts to put these high-tech components together?
Right.
Because looking at the geography of this boom, It is incredibly diverse. It's not just happening in traditional energy corridors.
No, the geographic spread is actually one of the most compelling parts of this entire shift. And that's because it's being driven by two completely different economic engines.
Okay, what are they?
On one hand, you have the replacement of legacy fossil fuels. On the other, you have the insatiable energy demands of the tech sector.
All right, just to run down the list of active development really quickly, we have Wyoming, where TerraPower just had their permit approved.
Right, and they are strategically building near retiring coal plants to utilize the existing transmission infrastructure.
Which makes total sense. Then we have Tennessee, which actually has two separate colossal projects with GE, Hitachi, and Kairos.
Yep.
Michigan is bringing in Holtec. Texas has a major industrial decarbonization project with X-Energy and Dow.
And then you have the tech giants jumping in to feed their data centers.
Right. So Washington State is looking at Amazon SMRs. Virginia has an Amazon and Dominion partnership. Indiana has GE Hitachi. New York is working with Constellation.
And of course, Pennsylvania with the historic restart of 3 Mile Island.
Wow. So that is 9 states representing just a tidal wave of capital.
And with that capital comes an unprecedented demand for labor. According to Smart Business Automator's Market Intelligence report, a single 4-reactor SMR project creates roughly 18,000 jobs per year for a 5-year build phase.
Wait, hold on. I have to demand a better breakdown on that math.
I know, it sounds crazy.
18,000 jobs per year, just for 4 modular reactors. Even with site security, administrative buildings, and grid connections, 18,000 people is the population of a small town.
It is.
If the reactor itself is 80% finished when it arrives on a flatbed, where are those thousands of labor hours actually going on a daily basis?
It's a critical pushback. And it really highlights the sheer scale of the infrastructure needed just to support the reactor itself. You have to remember that while the reactor core is modular, the nuclear island it sits in is not.
Okay.
You still have to excavate and build massive subterranean containment structures using specialized high-density concrete. You're building the turbine halls, the redundant cooling systems, the water intake structures, and, the heavily fortified security perimeters.
So the site work is still massive.
Exactly. But the real answer to your question about where those labor hours go lies in the integration. You absolutely need the general trades iron workers, concrete layers, electricians, but the absolute king of the SMR site, the trade absorbing a massive amount of high-value hours, is the nuclear-grade welder.
Because even if the modules arrive fully pre-assembled, they still have to be flawlessly connected to the broader plant infrastructure.
Right.
And the tolerance for those connections is literal zero.
Precisely. Nuclear-grade welders are the most in-demand and highest-paid trade on these sites. And honestly, they are currently creating a severe bottleneck for the entire industry.
Because there just aren't enough of them.
Right. The welds on these sites are holding back highly pressurized radioactive coolant. This isn't standard structural steel welding where you just lay a bead and move on.
Yeah, you can't just eyeball it.
No, this is microscopic perfection. It is often done using specialized techniques like gas tungsten arc welding in incredibly tight, awkward spaces. Welders are sometimes working with mirrors to see the backside of a pipe in a confined space. And every single millimeter of that weld is X-rayed, ultrasonically tested, and scrutinized by independent inspectors.
That sounds incredibly stressful.
It is an incredibly slow, deliberate process, so it's a massive opportunity for skilled trades, but also the biggest choke point for the contractors trying to execute these bids.
Which brings us to the business reality of this boom. With billions of dollars flowing and these massive labor demands, every single commercial contractor wants a piece of this pie.
Naturally.
But you can't just show up to an SMR site with a hard hat, a backhoe, and a good track record building commercial warehouses. The barriers to entry are practically a fortress.
They really are. And this raises the most important question for any construction firm listening today. How do you actually get your foot in the door?
Right.
The entry ticket to this entire ecosystem is something called NQA1 certification. That stands for Nuclear Quality Assurance. And it is one of the most rigorous, exhausting, and unforgiving quality management standards on the planet.
And for those listening who haven't chased federal energy or defense contracts, we need to be clear that NQA1 isn't just like a safety checklist you fill out on a clipboard.
Oh no, not even close.
It is a forensic accounting of every single physical atom on your job site. If you are a contractor under NQA1, you aren't just logging a steel bolt. You are tracking the origin of that specific bolt back to the iron ore mine.
Exactly.
You are tracking the calibration of the specific wrench used to tighten it, the ambient temperature of the room when it was tightened, and the certification of the worker holding the wrench.
And if an inspector finds a tool calibration record missing, work doesn't just pause for an hour.
Okay.
The entire multi-million-dollar section of the project can be halted for weeks while the paper trail is reconstructed.
Which is just terrifying from a budget perspective.
That's the exact reality. The level of traceability required is absolute. And practically speaking, to operate in this space, you need to partner with the prime contractors immediately.
Like right now.
The window to position a company is right now. Because once these SMR projects break ground, the prime contractors are going to lock in their qualified subcontractors for decades.
Wow, decades.
Yeah, the cost and friction of onboarding and verifying a new subcontractor under those NQA1 rules is so high that once a prime finds a sub they trust to maintain compliance, they will never let them go.
But getting that NQA1 certification and upgrading your fabrication facilities to meet these nuclear-grade standards is incredibly expensive.
It's a huge investment.
We are talking about millions of dollars in process overhauls, specialized testing equipment, and workforce training before you ever win a single bid. It's a terrifying leap of faith for a mid-sized contractor.
It is.
But the smart firms are getting incredibly strategic about financing this leap. They aren't draining their operational cash, they're utilizing SBA 504 loans.
Which is so smart because the financing strategy is just as important as the engineering strategy.
Exactly. For those unfamiliar, an SBA 504 loan is a government-backed financing structure designed specifically for major fixed assets like heavy machinery or facility expansions.
Right.
They usually involve a bank covering 50%, a certified development company backed by the Small Business Administration covering 40%, and the contractor only putting down 10%.
Only 10% down for a massive facility upgrade.
Yeah, it offers long-term fixed-rate financing, meaning a contractor can fund a $5 million facility upgrade to meet nuclear-grade fabrication standards while keeping their working capital free to actually run the business.
Yep.
They're basically leveraging small business financing to implement their NQA1 quality management systems so they can capture these generational infrastructure contracts.
It's a brilliant, highly leveraged strategy. It allows agile, forward-thinking contractors to punch way above their weight class and insert themselves into the nuclear supply chain without bankrupting themselves in the setup phase. But what's truly fascinating is that this demand for nuclear-grade facilities is creating a secondary boom.
The meta layer. I love this part of the equation. Here's where it gets really interesting.
Oh, yeah.
We've been talking entirely about the on-site construction of these reactors in places like Wyoming or Virginia. But to build the factory-made SMRs, the industry first has to build the module factories themselves.
Yes, the factory's building the factory.
Exactly. Facilities like BWX Technologies here in the US or Sheffield Forgemasters over in the UK, building these massive, ultra-precise nuclear fabrication facilities is a highly lucrative construction project in its own right.
It's massive.
So contractors aren't just bidding to assemble the reactors out in the field, they're bidding to build the multi-billion-dollar manufacturing plants in Ohio or Pennsylvania that will actually pump out the reactor modules for the next half century. It's a dual-layered construction boom.
It is. And both layers share the exact same underlying operational challenge.
Which is,
whether you are building the reactor site on the grid or the fabrication facility in an industrial park, handling NQA1 certifications, managing thousands of workers, and maintaining nuclear-level compliance is an administrative leviathan.
oh, I can only imagine. So we have a situation where a mid-sized contractor finally secures the funding, gets their NQA1 certification, and lands the bid. But the physical building is only half the battle.
Less than half, some days.
Right. The sheer volume of compliance paperwork required by the Nuclear Regulatory Commission is enough to bankrupt a company in administrative overhead alone if they aren't prepared.
Absolutely.
You can have the best welders in the world, but if a single request for information, an RFI or one non-compliant spec sheet is buried in a subcontractor's truck, the entire project stops.
Sure.
The paper trail is just as critical as the concrete. So, how are these firms actually handling that without collapsing under the weight of the bureaucracy?
That is exactly the pressure point, where projects either succeed or spiral out of control. Construction companies cannot scale to meet this demand by simply hiring armies of administrators. It doesn't work.
So what do they do?
They are solving this by leveraging AI platforms specifically built for the complexities of heavy construction. And Smart Business Automator's Market Intelligence Report shows that the capabilities of the Smart Business Automator platform itself are a perfect example of how this is executed in the field.
Let's get into the mechanics of that, because this is where the execution actually happens. Hold on. AI analyzing construction schedules isn't exactly brand new, right?
Oh, not at all.
Traditional software like P6 has been doing critical path analysis for years. So what makes this specific to the nuclear risk profile? How does AI actually keep an SMR project from grinding to a halt?
It comes down to natural language processing and the ability to understand context, not just dates on a calendar. It starts with information retrieval. In a nuclear project, you have millions of unstructured documents. Smart Document Organization automatically tags, sorts, and categorizes photos, plans, permits, RFIs, and daily reports as they are uploaded.
So no more manual filing.
Right. And then they use Smart Search, allowing teams to use conversational language to find project data instantly.
Give me an example of that.
Well, instead of a site manager spending 3 hours hunting through nested digital folders for a specific ultrasonic weld inspection report from 6 months ago, they just ask the system, and it retrieves it based on the context of the query.
That alone saves immense amounts of time, and it probably prevents the kind of panic that sets in when an inspector arrives.
Oh, exactly.
But what about communication? With 18,000 people cycling through a site, alignment across different subcontractors is everything.
It's everything. And the platform generates daily log and meeting summaries, extracting key takeaways and action items, so nothing falls through the cracks between the day shift and the night shift.
That's incredibly useful.
It even drafts RFI responses using historical project context and existing engineering records. That drastically speeds up the communication loop. But the absolute holy grail for nuclear construction, the thing that truly differentiates this from traditional software, is the compliance aspect.
Because of the NQAA1 standards we talked about.
Yeah.
The margin for error is 0.
Yes. The document intelligence tool doesn't just store files. It uses natural language processing to actually read complex nuclear specs.
Read them, like understand what they mean.
Yeah. For example, if the engineer's master specification requires epoxy-coated rebar for a specific containment wall, and a subcontractor uploads a daily log or a material receipt that mentions standard uncoated rebar,
Right.
well, the automated compliance checking reviews that active project information against the strict requirements.
Oh, wow.
And it flags the discrepancy instantly.
That is massive.
It reduces those incredibly expensive oversight risks before concrete is ever poured and long before an inspector ever steps foot on the site.
Think about the power of that. Connecting these AI workflows directly to the company's ERP systems, the central nervous system managing their accounting, procurement, and supply chain.
Right.
It essentially gives a construction company an omnipresent, hyper-organized digital project manager.
That's exactly what it is.
It allows human project managers to handle the immense scale and pressure of SMR projects without being buried in administrative audits. And simultaneously, it provides the executive leadership with vital, real-time project health monitoring.
Yep. They can see the change order impacts, the supply chain bottlenecks, and the compliance risks without waiting for a sanitized monthly report.
That changes everything.
If we connect all of this to the bigger picture, my core belief regarding this entire SMR boom is this. The construction companies that will dominate the next 60 years of heavy infrastructure aren't necessarily just the ones with the absolute best heavy equipment or the most skilled welders.
Even though you need those.
Right, you absolutely need those to play the game, but they are the ones with the best information management. The winners will be the firms that apply critical thinking to the concept of scale, adopting systems that allow them to handle nuclear-level complexity without organizational collapse.
It's a fascinating evolution of the industry, and it really forces you to look at the future of the built environment differently.
It really does.
It leaves me with one final thought, something for you to mull over after this deep dive ends. If we can successfully standardize, modularize, and factory build something as unimaginably complex, dangerous, and highly regulated as a nuclear reactor core, What other massive traditional infrastructure projects are about to be completely modularized next?
Oh, that's a great question.
Right. If we perfect this aerospace-style manufacturing for heavy civil work, what happens to the global desalination industry? Will we see massive direct air carbon capture facilities rolling off assembly lines instead of being built from scratch in the desert?
I wouldn't be surprised.
Will entirely site-built infrastructure eventually become a relic of the 20th century? It's something to think about. If you know a contractor who is looking to break into the energy sector or scale their operations without drowning in paperwork, send them this deep dive. It could be the blueprint they need to secure a decade of contracts. Hit follow on whatever app you're listening on so you don't miss tomorrow's intel. And be sure to visit smartbusinessautomator.com to learn more about the tools we discussed today.